Hi, thanks for joining me. Today I'm going to be going over problem 1 from week 3 of the Invariants Summer Puzzle Competition. As always, I'll leave a link in the description below to the Facebook page of the Invariants where you can find more details about the competition. Anyway, this is the problem I have for today. We have n being a natural number which is at least 3, so a positive integer which is at least 3, and a1 all the way up to an being natural numbers, so again a1 up to an being positive integers, such that ai divides ai minus 1 plus ai plus 1, and this holds for all I between 2 and n minus 1. We want to prove that Sn here, so this summation thing here, the sum from I equals 1 to n minus 1 of a1 an divided by ai times ai plus 1, we want to show that this guy here is always a positive integer. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so I've written up the main pieces of information that we need up here, so that ai divides ai minus 1 plus ai plus 1, and the thing we want to show is Sn, this summation term here, is a positive integer. The way we're going to do this is to just prove this by induction on n, so let's look at the base case, and now remember n is at least 3, so our base case is just n equals 3 as opposed to n equals 1. So when we have n equals 3, we have the S3, let's just use the definition, is the sum from I equals 1 to n minus 1, so the sum from I equals 1 to 2, of a1, a3, all over ai plus 1. But this thing here is just a summation of two terms, so let's just write it out in full. So it's a1, a3 divided by a1, a2, so that's when I equals 1, plus a1, a3 divided by a2, a3, when I equals 2. And then let's put everything under one common denominator, and that common denominator is going to be a1, a2, a3, hopefully quite clearly. So this thing here becomes a1, a3 squared, all over a1, a2, a3. And this thing here becomes a1 squared times a3, all over a1, a2, a3. But now just bringing everything together, if we bring the tops together and factor out an a1, a3, we get a1, a3 times a1 plus a3 divided by a1, a2, a3 like so. Clearly the a1, a3 is going to cancel with that a1 and that a3, and all we're left with is a1 plus a3 divided by a2. But if we go back up to here and plug in I equals 2, we have that a2 divides a1 plus a3, and that's given to us. So that means that this thing here must be an integer, certainly, and it's very clear to see it's going to be a positive integer because the top is positive and the bottom is positive. So in fact, we get that this thing here is a positive integer, so a natural number. Okay, so that proves the base case when n equals 3. Now what we're going to do is assume it holds for all, so we're actually going to do this by strong induction, I should have said. So we're going to assume it holds true for all k less than some n, and then prove that it holds true for that n as well. Anyway, let me clean up the whiteboard and we'll continue. Okay, so as I said, what we're going to do is suppose that sk is a positive integer for all k less than some positive integer n, and then we'll show that Sn is also a positive integer, and then we'll be done by strong induction. But before we do that, I kind of want to derive a kind of recurrence relation between the SI's using this guy here, and that will allow us to prove that Sn is also a positive integer. So let's just take an arbitrary subscript of Sn. So let's look at SL, but we'll actually look at the next term across, so SL plus 1, like so, and see if we can write this here in terms of SL. Well, if you just plug it into our definition here, it's the sum from I equals 1 to L, because n minus 1 is L plus 1 minus 1, so L of A1, AL plus 1, divided by AI times AI plus 1, like so. Okay, let's just factor out the AL plus 1 from the top, and then kind of introduce an AL, so you'll see what that means now. Okay, so I've factored out this AL plus 1 from the top, and I've introduced an AL here, but that's going to cancel with that AL there. So this is still the same. And I'll notice that this thing here is a summation from I equals 1 to L of A1AL over AI times AI plus 1. So it looks very similar to Sn, except now we're summing to L as opposed to L minus 1. But that's fine, we can deal with that by essentially writing this summation as a sum from I equals 1 to L minus 1, and then just adding on the Lth term as well. So this is AL plus 1 divided by AL times, well, if we do the sum from I equals 1 to L minus 1 of that guy there, that is just SL by definition, but then we've got to add on the Lth term. The Lth term is just A1AL divided by AL times AL plus 1. Now of course the AL and the AL cancel there nicely, and then we've got an A1 times AL plus 1. So if we just go ahead and expand this out, this is equal to AL plus 1 divided by AL times SL plus A1 divided by AL plus 1 times AL plus 1 over AL, so just A1 over AL. Now we have SL plus 1 is equal to AL minus 1 divided by AL times SL plus A1 divided by AL. So if I just multiply through by AL and rearrange a little bit, I'll get the SL AL times SL plus 1 minus AL minus 1 times SL is equal to A1 like so. So just squeezing it in at the bottom there. But this is a recurrence relation, so if we know what SL is, we can work out what SL plus 1 is from this recurrence relation here. And what I'm actually going to do is use this guy here to help me prove that Sn is a positive integer. But before I do that, let me clean up the whiteboard. Okay, so I've written down the thing we just proved, AL times SL plus 1 minus AL plus 1 times SL equals A1, and now we're going to show that Sn is also a positive integer. So just using this formula here and plugging in L equals n minus 1, we can rearrange and then work out what Sn is in terms of Sn minus 1. So we just get Sn times An minus 1 minus An times Sn minus 1 equals A1. So then just bringing everything onto one side, we get that Sn is equal to A1 plus An Sn minus 1, all divided by An minus 1, like so. So we want to show that this guy here is a positive integer. Well, it's very clearly positive because the top is positive and the bottom is positive. So essentially we want to show that this is an integer. But this is an integer if and only if, so this is an integer, if and only if this guy here is an integer. Let me just write it down, minus A1, An minus 2, plus An, Sn minus 1, all divided by An minus 1. Now why do I claim that this is true? Well, because the thing that I've added on the numerator, this minus An minus 2 plus An times Sn minus 1 divided by An minus 1, well, we know that guy here, so this thing here, is also an integer. And the reason we know that is because, well, Sn minus 1 is an integer by assumption from this guy here. And also, An minus 2 plus An divided by An minus 1, well, that's also an integer because we have this guy here. So An minus 1 divides An minus 2 plus An. So this guy here is a positive integer multiplied by a positive integer, so certainly it's going to be an integer. Then of course we've got the subtract here, so this thing could be negative, but that's fine. We already know that it's positive from this guy here, or we know that this thing's positive, and we want to show that it's an integer. It's an integer if and only if this guy here is an integer. But now we can actually do some cancellations because we've got a minus Sn minus 1 here, and minus An times Sn minus 1, and a plus An times Sn minus 1. So that's going to cancel with that. So I'm left with A1 minus, let me just write it here quickly, A1 minus An minus 2 Sn minus 1 divided by An minus 1, like so. So we want to show that this thing here is an integer. But if we just have a look at what we have up here, this thing here is precisely Sn minus 2. Okay, and I'll just hopefully let you just see that for a second, but just if you plug in L equals n minus 2 into this thing here and rearrange, you get that, into this guy here, and plug it in and rearrange, you're going to get that this quantity here is exactly Sn minus 2, and then that proves our claim. Because of course by induction, or by assumption, Sn minus 2 is an integer, and hence this guy here, Sn, is an integer, and then we're done by induction. Anyway, I hope you have enjoyed this video. Thank you for watching. I'll catch you in the next one. Have a great day.